We're going to go over waves. Mechanical waves needs medium, like transversal wave, water, for example, water waves, and longitudinal wave like sound wave. They do need medium. For example, if I go to moon and try to talk to you, you ain't here because there is no air on the moon. So mechanical waves needs medium, and mechanical waves, there are two types: transversal wave and longitudinal wave. Transversal wave, the particles oscillate perpendicular with respect to the motion of the wave, and the longitudinal wave, the particle moves parallel with respect to the velocity of the wave, right? And you have EM waves need no medium. However, EM waves also can move through the medium. When they do move through the medium, they slow down. Why is that? Because velocity is c over n. N is the index of refraction. All right, so the case study for mechanical waves, we're going to use seismic wave, right? Seismic wave is a case study for mechanical waves, and for EM waves, we're going to use case study as well, like a Doppler effect. Now, there are 5 aspects of waves, and they are you have the period, you have the frequency, you have the amplitude, you have the wavelength, and you have the in phase. And we also have 6 and 7 characteristic behavior. You have reflection, you have refraction, you have diffraction, you have Doppler effect, and you have interference, superposition, and also we're going to go over a critical angle. So this is what we're going to do in this tutorial. So let's dive in. So let's start our conversation by writing simply waves. All right, waves are two types. We said that, to mechanical and EM waves, electromagnetic waves. In EM waves, this is electric field, this is magnetic field. How that look like? This is electric field, up and down, up and down, up and down. This is magnetic field. This is magnetic field, out and in, out and in, and they are perpendicular with respect to each other. So this is transversal. So transversal. All right. So mechanical waves, they do need medium. Without medium, they cannot move. EM waves, they cannot move through the vacuum. Now, EM waves, medium, yes, vacuum, yes. When they move to the vacuum, so speed of the light is velocity is 1 is square root of epsilon times you have mu. So this is 3 times 10 raised to 8 meter per second. And when they moved through the medium, velocity is c over n. So for example, 3 times 10 raised to 8, and n is 1.33. So this is 2.5 times 10 raised to 8 meter per second. So this is water, and this is air. When light moves through the water, this is the velocity. When light moves through the air, this is the velocity. Okay, so mechanical waves, there are 2 types. You have a transversal and you have a longitudinal. Transversal, of course, you look like a sinusoidal. Okay, so what happened? The little particle, they move up and down with respect to the direction of the wave. If the wave moves this way, they move perpendicular with respect to the direction of the wave. Okay, so perpendicular. You have longitudinal wave. So example is water wave. Okay, longitudinal wave, it should look like this. So this is our crest, and this is our trough. So this is our crest, you're gonna say compression, and this is, you're going to say rare fraction. All right. So crest to crest, you're going to say wavelength, and compression to compression, we can also say wavelength. Okay, good. And now, so now let's see all 5 aspects of waves. Okay, so before that, let's see how the waves look like. Okay, if you have a wave, let's say, so let's say this is, you have 3, this is -3. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Okay, so okay, great. So you have 3 to -3. Now how can we write this wave? We want to write the equation to show that I give you the position and the equation give you the height. So the equation must be, if you input the position, all right, this wave is a snapshot. Let's say t is equal to 0 seconds. Someone took the picture of this wave from the ocean. So this is what's going on in the ocean. So someone take the picture at t is equal to 0 seconds. Now you have to analyze it. What is going on? At what location? The height is whatever it is. It could be 3, it could be 0. Can height ever be 4? No. Can height ever be less than -3? No, it can't. So can height ever be 3? Yes. Can height ever be -3? Yes. Okay. So for example, at 4, when position is 4, the height is 3. So we want to write an equation. How can we do that? Let's see. Y is x is a sine bx plus c plus d. Is there any vertical shift? No. What is the amplitude? Amplitude is 3. All right, amplitude is 3. Okay. Sine bx. What is our b? Let's see. B is our period. So this is period. This is phase shift. So is there any period phase shift? No. So we're just going to write bx plus 0 plus 0. All right. So yx is equal to 3. We can also say this is a wave number instead of period. This is wave number. So we're going to actually replace it by kx. What is k? K is 2 pi over lambda. Okay, so you're going to replace this one 2 pi over lambda. So 3 sine 2 pi over lambda x. Right. Now, what is the lambda? Let's see. The lambda is from here to here. This is cosine, by the way. So we're going to have to make sure that this is cosine. So what is lambda? Lambda is from here to here, crest to crest is the lambda. So lambda is 4 meters. So you're going to write 3 cosine 2 pi over lambda 4. Right? X. This is x. You're going to write 4 here. X, we have to keep it as a variable because x takes input position and it gives you the output, which is the height. So now y of x is equal to 3 cosine. You have pi over 2x. All right, let's see. Let's test out. Let's put 0. If you put 0, this is the whole thing is 0. So cosine 0 is 1. 1 times 3 is 3. So y is equal to 0 is 3 cosine 0, which is 3. Y is equal to, let's say, 8. When position 8, height must be 3. Let's see whether we get 3. Cosine pi over 2 times 8. So this is 4. So y of 8 is equal to 3 cosine 4 pi. As you know that this is 4 pi. Okay, so what is it? This is 1 comma 0. All right, so cosine, when cosine for y is 1, so 3 times 1, which is 3. So, and that's true at 8, when position is 8 meters, the height is 3 meters. So let's go to the other direction, right? The last problem, I gave you the graph and you turn graph to an equation. This time I'm going to give you an equation. You're going to turn the equation to graph. So what do you know about waves? Y is equal to A sine bx plus c plus d, right? What do you know about A? A is amplitude. B is period. C is phase shift. D is a vertical shift. All right, so now let's put some numbers. Let's put 2 sine x minus pi over 4 plus 3. All right, now make the list. Amplitude is amplitude is 2. All right, what do we see that? We see period. Before, yes, sure, period is number 2. Period is 2 pi over b. So 2 pi over 1, because b is 1. 1 is sitting next to x. So period is 2 pi. All right, good. Number 3, frequency is by definition is 1 over period. By definition, frequency is 1 over period. So 1 over 2 pi. Right? Good. Number 4, velocity. Velocity is period. Velocity is lambda. Okay, so we need to find lambda. So wavelength. The wavelength is also 2 pi over b. Let me explain. What is wavelength? Wavelength is the period in space. So wavelength is period in space. What does that mean? Then can we say that the period is the wavelength in time? So can we say that period is then wavelength in time? Yes, but there is a condition. If they are connected by the velocity. If they are connected by the velocity, then we can say that wavelength is the space, wavelength is the period in the space, and period is the wavelength in time. If they are connected by the speed, which is velocities, lambda over t. If and only if velocity is lambda over t. Okay, so what does that mean? Our wavelength then is 2 pi. Okay. Then what is our velocity? Velocity is lambda over t, which is lambda times f, which is or we can say lambda is we can say lambda over t, it doesn't matter. Lambda is 2 pi and f is 1 over 2 pi. So velocity is 1 meter per second. Upper limit is 3 minus 2. Upper limit is 3 plus 2. Lower limit 3 minus 2. Equilibrium 3. Phase shift. Hopefully you see it. Phase shift. Pi over 4. Since our period is 2 pi, you're gonna have to have, you're gonna satisfy, we must satisfy 2 pi. So the distance from here to here has to be 2 pi. How can we satisfy the distance which is 2 pi? They are connected 2 pi. Well, if our first one is pi over 4, okay, it's going to be difficult to satisfy this condition. So pi over 4 plus what going to give you 2 pi? All right, so pi over 4, so pi over 4 plus 2 pi. So let's multiply. Top is 2, bottom is, top is, I guess, 4, bottom is 4. So you have 9 pi over 4. So this is 9 pi over 4. We need 5 points to draw the graph. So this point must be, this is 1 pi over 4, this is 3 pi over 4, this is 5 pi over 4, this is 7 pi over 4. And the distance between 1 pi over 4 to 9 pi over 4 is 2 pi. All right. This is our upper limit, which is 5. This is our lower limit, which is 1. This is our equilibrium. This is our equilibrium, which is 3. We're going to use this to complete our graph. This is every point in this unit circle defined by x and y. X is cosine theta, y is sine theta. So this is 1 comma 0, this is 0 comma 1, this is what? Negative 1 comma 0, this is 0 comma negative 1. This is 0 radian, this is pi over 2, this is pi, this is 3 pi over 2, this is 2 pi. All right, so this is 0 degree. Why this is 0 degree? Because pi over 4 minus pi over 4 is 0. This is 90 degree. Why this is so? Because 3 pi over 4 minus pi over 4 is 90 degree. Why this is 180 degree? Because 5 over 4 minus pi over 4 is 180 degree. Why this is 270 degree? Because 7 pi over 4 minus pi over 4 is 3 pi over 2. Why this is 360 degree? Because 9 pi over 4 minus pi over 4 is 2 pi. All right. So now if you 0 degree, right? Sine 0 degree is 0. So 0 times 2 is 0. 0 plus 3 is 3. We get our first point. Sine 90 degree is 1. 1 times 2 is 2 plus 3 is 5. Sine 180 degree is 0 times 2 is 0 plus 3 is 3. Sine 270 degree is negative 1 times 2 is negative 2 plus 3 is 1. This is not working. Sine 360 degree is 0 times 2 is 0 plus 3 is 3. Oh, this was 1. This is 3. Okay, so we have all our points. We're going to graph it now. Okay, good. This is what you learn 7th grade or 8th grade, this wave equation. Now we're going to really have to add some new knowledge to our storage. Right? And that is the real wave equation. Wave that is moving. This is not quite wave. This is a snapshot of the wave. Now we're going to have to learn the wave that is moving. Okay, let's try to do that one. Wave that is moving. Okay, so what I'm talking about, wave that is moving. I'm talking about psi x comma. Okay, this is a snapshot, an upward snapshot. Now, wave that is moving because the position changes with respect to the time. So we have the time variable finally. Very good. So you have a sine omega t minus kx. Omega is angular frequency. All right, so what is omega? Omega is 2 pi f. So omega is 2 pi over t. What does that mean? That means this is 2 pi, right? And this is t, right? Okay. The time it takes to complete one cycle, which is 2 pi, which is 2 pi f or 2 pi over t. That's the angular frequency. And this is wave number. So k is 2 pi over lambda, right? Okay. 2 pi over lambda. Okay. So 2 pi over lambda. Okay. So now let's see. Velocity is defined by omega over k. So what is omega? Omega is 2 pi over t. Okay. And what is k? 2 pi over lambda. So 2 pi over t times, you flip that, lambda over 2 pi. 2 pi cancel. So velocity is lambda over t. So velocity is lambda times 1 over t. Velocity is lambda, 1 over t is f. So velocity is lambda times f. You knew all along that velocity is lambda times f. You see it again with respect to the wave equation. Now, let's put number to this wave. This wave is moving to the right. We can make it moving to the left. Doesn't matter. Say x comma t is equal to 0.1 sine 4 pi t plus pi x. If I ask you to take a picture at 0 second, then how will this gonna look like? Okay, before do that, let's find some values. All right. So let's see. If you put omega. Okay, if I ask you to take a picture at 0. 0 second, how would that look like? All right, let's do it. X 0, 0.1 sine 4 pi t plus pi x. To draw it, we have to understand how many cycles we have to draw, so that we have to check with the angular frequency. Angular frequency, oh, we don't have it. All right, so let's write those things. Amplitude, number one, let's write from here. Amplitude is 0.1. meter. Number 2, angular frequency. Angular frequency is omega is equal to 2 pi f, right? So, and that is how much? Is 4 pi. And then frequency, number 3, frequency is equal to omega is 2 pi f. So omega is 4 pi is equal to 2 pi f. So then frequency is 4 pi over 2 pi. So frequency is 2 hertz. And this is very important to draw the wave because the wave completes 2 cycles every second. So let's draw it then. Wave completes, all right, this is x, this is y, this is x, and t is equal to 0. Wave completes 1 cycle, 2 cycle every second. Okay, good. So 2 cycle, we know it from the equation that wave completes 2 cycle every second. So 2 cycle, not 1 cycle, not 3 cycle, 2 cycle, because wave completes 2 cycle every second. Good. Number 4, wave number. So wave number is 2 pi over lambda, right? Okay, so what is wave number? Wave number is pi. So what is wavelength? Wavelength is then, wavelength is 2 pi over k. So 2 pi over k is lambda. So 2 meters. So the wavelength is then 2 meters. So how much the wave moved? 4 meters, because if 1 cycle is 2 meters, then 2 cycle is 4 meters. Total distance the wave move is 4 meters, but the wavelength is 2 meters. So wavelength is 2 meters. Good. What else we need to know? We need to know velocity. We can find velocity 3 different ways. Let's find 3 different ways. Velocity is omega over k. What is omega? Omega we have over here. What is omega? Omega 2. Omega is how much? That's frequency. Omega is 4 pi. So 4 pi. And what is wave number pi? Oh, velocity is 4 meter per second. That's one way. Second way, velocity is distance over time. So velocity is distance is 2 meters. Have we ever find the period? Oh, we did not find the period. So let's find the period. The period is 1 over frequency. So 1 over frequency is 2. So 0.0, or 1 over 2. 1 over 2 seconds. All right. So this is 1 over 2 second, or 0.5 second. So velocity is 4 meters per second. Let's find the final way, velocity. Velocity is lambda times frequency. So velocity is lambda is 2. Frequency is 2. So velocity is 4 meters per second. Now let's see how this wave look like at sometime in the future. Let's say how time, let's say, I don't know, 1 over 4 second or 0.25 second. 0.25 second, this wave gonna look a little different than what it is now. Okay, hopefully I can do it here, right? At point, so at 2 point, this one is t is equal to 0 second, this one is t is equal to 0.25 second. This wave gonna look like psi x comma 0.25 second is 0.1 sine 4 pi 1 over 4 plus pi x. So psi k x 0.25, or I'll just write 1/4 is equal to 0.1 sine 4 cancel your pi plus pi x. So sine a plus b. So sine a cosine b plus cosine a sine b. A is pi, b is pi x. So sine pi cosine pi x plus cosine a is pi, sine b is pi x. This is pi. This is 1 comma 0. This is this is 1 comma 0. This is negative 1 comma 0. This is 0 comma 1. So this is pi. This is 0. Sine pi is 0. So sine pi is 0. So this whole thing is 0 plus cosine pi is negative 1. So this is negative 1. And sine pi x. All right, so we're going to write what we discovered. Psi x comma 1/4 negative 0.1 sine pi plus pi x is just pi x. Okay, that's what we're going to draw now. If this looks like this, that one going to look like, of course, 2 cycle. However, this is 180 degree. 180 degree phase shift, but it has to be 2 cycle. 1 cycle, 2 cycle. It's 2 meter. So this is 4 meter. Okay, and this is x. This is y. This is x. Okay, everything else is gonna be. You should be able to do everything else from here. And this phase shift, this is 180 degree phase shift. We're gonna be talking toward the end of this tutorial when we go over the properties. There are 6 properties of wave and 6 characteristics of waves. To the end of this tutorial, we're gonna talk about the properties and characteristics, and hopefully you will have like 360 degree understanding. So let's start with the velocity. And then you have a period, and then you have a frequency, and then you have amplitude, and then you have wavelength, and then you have in phase. All right, so this aspect we're going to try to understand in next few minutes. So velocity, let's try to understand the velocity. Let's say you take a rope, right? You take a rope and you create a pulse, right? How can you create a pulse? You have to move up and down to create a pulse only once, maybe. All right, so to create a pulse, right, you need to transfer tension to the rope. How can you transfer tension? By applying force. So tension has to be there. All right, tension. Who is creating tension? You applying force. That's force is the tension force. If the tension force is 0 on the rope, then of course the rope velocity would be 0, and the rope not going to move with velocity v. So okay, so velocity is connected with tension. Velocity is connected with force. Tension is type of force. Okay, good. All right, what else? If rope is like a big, like huge rope, then it would be very difficult for you to create the tension on the rope. So some type of like mass really affecting the velocity, impeding the velocity. All right, so you're gonna keep that in consideration. So velocity probably gonna be tension over something, over, let's say, 2 things. Let's say mass over our linear density. So what is density? Density is kilogram over cubic meter. Linear density is just kilogram over meter. Kilogram over meter. So mass over mass over length. Okay. So let's see whether the dimensional. Let's take a look at the dimensional analysis. All right. So velocity is F is Newton, mass is kilogram, length is meter. Okay. So this is what we have. So Newton, as you know, kilogram meter per second squared, and you have kilogram over meter. All right. This is velocity, right? So what do you get? Velocity is then kilogram meter per second squared, kilogram meter over second squared. You flip it. If you flip it, is going to be meter over kilogram, kilogram cancel, velocity meter square over second square. Voila! This is not the SI unit for velocity. SI unit for velocity is meter per second. This is not meter per second. So what are you going to do? We're going to take the square root, of course. So we take the square root. So velocity is meter per second. What does that mean? That means the velocity is equation is ft over mass over density. Okay, all right. So let's solve a problem. Let's say ft is 100 Newton. Okay, mass is 0.1 kilogram, and mu is let's say 10 meter, I guess. Let's say rope is 10 meters, so let's say mu is 10 meters. All right, so what are you going to do now? Velocity is square root of, well, we have 100 over 1 over 0.1 over 10. So you have 100 divided by 1 times you have 10 and you have 0.1. So you have 1, 2, 3, 1, 2, 3, 4, 0. Okay, square root of 4, 0, you have only 2 zeros, so 100. Okay, so velocity is 100. So this is moving with velocity 100 meter per second to the right. Okay, so we also going to see the other aspect of the velocity. What are the other aspects of the velocity? Oh, by mistake I erased it. Okay, but don't worry, I'm going to write them again. So the other aspect of the velocity would be we daily experience, let me see what time it is. Okay, daily we experience 3 states of matter: solid, liquid, and gas. So you have a solid, liquid, and gas. All right, solid, you have a, velocity is very big, liquid velocity is second big, and then gas velocity is very small. Now, why in the solid the velocity is really big? Velocity of who? Velocity of sound. Everything we are doing, sound, which is longitudinal wave. Velocity of sound, and then we're going to do, of course, velocity of light too. All right, in a second. All right, velocity of sound and velocity of light, we're going to do a medium and not medium. Okay. Velocity of sound, as you see that if you move from different medium, then velocity of sound increase or decreases. All right, the gas, we're going to say this is 15 degrees Celsius, and the liquid 15 degree, everything is 15 degrees Celsius. Okay, all right. So first, let's go over solid. Solid, okay, so solid, something called velocity depend on two things. One is bulk module and one is density. What is bulk module? let's say I have something and I want to deform it. If it was a balloon, then it would be easy for me to deform. All right, so its steepness, this one is not so easy to deform. But if I have like a hammer and I hit it with the hammer, I would be able to deform this one. So deform is like when you strike something, it says no to the deformation because it doesn't want to deform. It want to stay as it is forever. But then what is then how you ever going to deform it? Well, if you really overcome the inertia, then you would be able to deform it. So the bulk module is strain over stress. Okay, so how much stress over strain? How much stress do you have to apply? How much force you have to apply to deform it? Okay, good. So that must be in pressure, and this is density. Okay, and then square. Now for solid, this is 2 times 10 raised to 11. So you're going to write 2 times 10 raised to 11. And for solid, this is 8,000 kilogram per cubic meter. So you have velocity is 2 over 8 times 10 raised to 11, and you have minus 3. Okay, so velocity is 2 goes to 8 fours, so 1 over 4 times 10 raised to 8, right? Okay, so now if you square root this, you square root that, what do you get? You get 1 over 2, and you get what? This is 2, this is 4, 10 raised to 4. So velocity is, this is, you get 0.5, and this 10 raised to 4. So velocity is 5,000. All right. So velocity of sound in the solid is 5,000. And let's say in the liquid, velocity is a bulk module B over density. Bulk module for water is very small compared to the other one, 2 times 10 raised to 9. And density for water is 1,000 kilogram per cubic meter. All right, now velocity is, you have 2 times 10 raised to 9 minus 3. So velocity is 2 times 10 raised to 9 minus 3 is 6. So square root 2 square root this. So you have 1.4 times 10 raised to 3. So your velocity is about 1500 meter per second. All right, velocity of the sound in the water is about 1500. Now say velocity of the sound in the gas in this room. Okay, in the air. Gas means air, by the way. So hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, neon, fluorine, and then what? Sodium, and then magnesium, and then aluminum, and then silicon, and then phosphorus, and then sulfur, and then chlorine, and then argon. So there are 3 gas this room made of, and that is, you have nitrogen, you have oxygen, and you have argon. Okay, so this room made of nitrogen gas, N2. This room made of oxygen gas, O2, and this room also made of argon, right? So this room made of nitrogen, how much? 78%, 21%, and this is 1%. Altogether is almost 100%, right? Now, what are we going to do? We're going to take the molar mass. So what is the molar mass? Molar mass is nitrogen. Nitrogen is 1, 2, 3, 4, 5, 6, 7. So this is 7. What is 7? Atomic number. 14. What is 14? Atomic mass, right? So now, since this is nitrogen gas, there are 2 nitrogens. 14 times 2, which is 28. So you're going to write 28 times 0.78 plus oxygen. This is 7. This must be 8. Then this must be 16. There are 2. So 2 times 16, 32. 32 times 0.21, and plus argon. Argon is 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18. All right. However, there is a famous argon isotope, who is neutron would be not 18. So in this case, proton is 7, neutron is 7. Proton is 8, neutron is 8. In this case, proton is 18, but neutron not 18. I believe neutron are 22. So that's why this is going to be, that's why 18 plus 22, and that is 40. So you're going to write 40. All right, so this is 40. So 40.01. Okay, so this is which is molar mass. What is the molar mass here? Molar mass 0.03 kilogram cubic meter. All right, now let's see the velocity. So velocity is, you have heat capacity, you have the gas constant, you have the temperature, and the molar mass. So you have 1.4, you have 8.314 at 0 degrees Celsius. This is 0 degrees Celsius. This is Kelvin. 0 degrees Celsius. At 0 degrees Celsius, the speed of sound is 331. So then if temperature increases, of course the speed increases. How is that? Velocity is dependent on temperature. 331 plus 0.6 T. What does that mean? Every 1 Celsius increase of temperature is 0.6 increase of velocity. 0.6 meter per second increase in velocity. Okay, now let's see the aspect. What time it is? 40. Okay, we have few seconds. So let's see the light. The speed of sound in different medium in light. Two medium we're gonna consider. Okay. All right. So this was, you saw that mechanical speed of sound, because the speed of sound need medium. So it use rope as a medium, it use air as a medium, it use water as a medium, it use solid as a medium. Now speed of light, it doesn't need medium, but it can also move to the medium. So light. So when light moves to the vacuum, and when light to the medium. All right. So what is the speed of light? Okay. So when it moves to the vacuum, speed is, velocity is lambda times frequency. Very simple. And when it moves through the medium, is velocity is you have c over v. Okay. So lambda times frequency. Let's use the blue light and red light. So I have a blue light and I have a red light. The blue light, let's put red first and then blue. All right. The red, you have a big lambda. You have a big lambda. The blue, you have a big frequency. So if the lambda go up, the frequency must go down to keep the speed of sound, which is 3 times 10 raised to 8 in the vacuum. If the frequency is big, lambda has to be small, so that it has to keep the speed of light, which is 3 times 10 raised to 8 meter per second. All right. Now, let's consider one thing over there, and that is lambda. Lambda is, of course, for LED light, lambda is bigger, so 600 nanometer. So 600 nanometer. Lambda is 600 nanometer. And lambda is small, 500 nanometer. Okay, so speed of light is, okay, let's do it, do the red here. Red, speed of light is, velocity is lambda times frequency. This is red. So velocity is, lambda is 600 nanometer, which is 600 times 10 raised to negative 9 meter. Frequency is 500. So 5 times 10 raised to 14 hertz. So velocity is 6 times 5, 30, 1, 2 times 10 raised to 9 minus 9 plus 14. meter per second. So velocity is equal to 3000 times you have 5, 10 raised to 5. Is that right? Yeah, 5 meter per second. So 5 plus velocity is 3 times 10 raised to 3 plus 10 raised to 5 meter per second. So velocity is 3 times 10 raised to 8 meter per second. Right. Now let's see the blue light. Okay, so the blue light, let's do the blue light here. Blue light. So we're going to call it C because this is 3 times 10 raised to 8. Now blue light, you have velocity is small lambda but big frequency. So lambda is 500 nanometer times 10 raised to negative 9 meter, and frequency is 6 times 10 raised to 14 hertz. Okay. So the frequency go up because lambda go up. Frequency lambda go up, frequency go down. Okay, whatever. So this is 30. You have 5 times 6 is 30, and you have 20. All right, so 3000 times 10 raised to negative 9, and 14 is 5. So 3 times 10 raised to 8 meter per second. Okay, so now at the end of the day, which is C, at the end of the day, velocity doesn't matter. It's blue light, red light, ultraviolet, yellow, green, gamma ray, X-ray, radio wave, long radio wave, doesn't matter. At the end of the day, velocity is velocity 3 times 10 raised to 8 if it moves to the vacuum. But if it is moved through the medium, then of course this is not 3 times 10 raised to 8. So let's see it moves to the medium. When it moves to the medium, which is velocity is c over n. So let's say it moves to the water. It's going to move slowly in the water. Okay. So velocity is 3 times 10 raised to 8 divided by the index of refraction for the water is 1.33. So the light is going to move 2.5 times 10 raised to 8 meter per second. Period and frequency. We'll try to understand with these examples. All right, I have 1A, I have 1, 2, 2 cycles. Let's say this is 4 seconds. That means this is Y and this is T. And 1B, 2A, let's call it 2A. I have 1, 2, 3, 4 seconds. And let's say this is also 4 seconds. And this is T, this is Y. And 2A, we're going to keep exactly the same thing. All right. So 1, 2, and we're going to say 4 seconds. And 2B, we're going to keep exactly the same thing, 4 cycles. 1, 2, 3, 4. This one is going to help you really understand the differences between period and frequency. We're going to use this 4 scenario to derive a definition and so on. So I'm going to put a circle around the cycle. Okay, so I did what I did. Now, can you use these 2 pictures to create a definition for period? There you go. So the period is time it takes to complete one cycle. Time takes to complete one cycle. That's the definition of period. Okay, now let's see. If we apply this definition, we should get the right answer. So period is the time it takes to complete one cycle. How much? 2 seconds. The time it takes to complete one cycle. How much? 1 second. Now let's see whether our the equation. Let's see, we can also write an universal equation that also solve the problem a little different way. Okay. So we're gonna say this is period. In the part, this is period. This is frequency. So what are you going to do? Period is, so you're going to write period is total time over total cycle. So period is total time over total cycle. So what is total time? Total time is 4. Total cycle is 2. 4 divided by 2 is 2. Check. Total time is 4. Total cycle is 1, 2, 3, 4. So 1 second. So check. All right. So the definition we created using the picture is as powerful as the equation itself. So it's always good to have multiple options to solve the problem. Okay. I'm going to give you a picture. So you want to write the definition of frequency. It doesn't look good. Okay, so I'm going to actually use this. All right. So now let's write the definition of frequency using this picture. So frequency is number of the cycle. Frequency is cycle completed in 1 second. In 1 second. Let's say use this definition. All right, so frequency is then how many cycles are completed in 1 second? Just half cycle. We call it cycle over second, which is hertz. How many cycles we completed in 1 second? Just 1. Frequency is 1 hertz. Now, let's see whether we can create a universal universal definition to an equation. So the frequency would be, well, frequency is just inverse of this one. So let's flip it. Total cycle over total time. So frequency is over total time. So total cycle is how many cycles? You have 2 cycles. How much time it took? 4. 2 divided by 4 is 1 over 2. And the check. Total cycle 1, 2, 3, 4. Total time 4. 1. Check. I believe that after this demonstration, you have no confusion between period and frequency. Let's quickly go over amplitude. So amplitude is from, this is equilibrium, yx, x is the equilibrium, all right. So the distance from crest, so let's say this is 5, to equilibrium is the, what do you call, amplitude. So amplitude is 5 meter. So now what if I give you something difficult, then it's not so obvious. Or you can say, and this is 5. So the distance from the equilibrium to trough is also amplitude. So how? Amplitude is absolute value. So 5 meters. So amplitude is -5 meters. So 5. However, if this is not so obvious and I give you something difficult, then how are you going to do it? Let's say I give you something like that. This is -2, this is 8. Okay. And this is not equilibrium, definitely. Why? Because -2, okay, right, there is a midpoint between -2 and 8. You have to find it. What is the not midpoint, mid-range. Mid-range is max plus mean divided by 2. So max is 8, mean is plus minus 2, so it's 3. So yeah, midpoint is 3 using mid-range formula. So yeah, you're gonna move this line to here. So you now can call it equilibrium, right? Let's see whether this equation works for that. So the mid-range formula is max plus mean divided by 2. So mid-range is, max is how much? 5 minus 5 divided by 2. So mid-range is 0 over 2. That gives you 0. So equilibrium is 0. Is that true? Yeah, this is 0. Yeah, 0 is, this is -5, this is +5. So this must be 0. 0 is sitting between -5 and +5. Okay, so mid-range, well, in this case, you don't have to use the mid-range. Is that because this is already equilibrium? The negative, +5 and -5, so it's already in equilibrium. So you don't have to use, but in this case, you do have to use the, probably use the mid-range. You just don't want to make any mistakes. One more example. Let's say this is 15 and this is -3. So mid-range will give you 15 minus 3 divided by 2, and that is 12 divided by 2, which is 6. All right, so now this is 6. All right, how that makes sense? Because 6 is sitting between -3 and 15. So what is the equilibrium? Equilibrium must be 6 plus what is 15? 4, 9. So equilibrium. So the amplitude must be 9 from equilibrium to crest or equilibrium to trough. Finally, we're going to try to understand the wavelength, right? After that, we're going to be talking about 6 properties of waves and 6 characteristics of waves. So wavelength. So the definition of wavelength would be, wavelength is measured in meter. So the definition of wavelength is the 2 points, 2 successive points, right? 2 consecutive points in phase. Let's translate this one in graph. I'm going to give you 2 problems. 3 cycle, 1 cycle, 2 cycle, 3 cycle, y-x, y-x. I'm going to give you 1 point here, right? I'm going to give you 1 point here, and I'm going to give you 1 point here. I'm going to say A, B, and C, right? I'm going to do the same thing. Well, I'm going to give you 1 point here, 1 point here, and 1 point here, and I'm going to say A, B, C. It's A to B a wave, A to B, and I'm going to say A to C. To be wavelength, you have to pass 2 things. Consecutive, I don't need this one. A to C. So we're going to say A to C here. Consecutive in phase. A to C, consecutive and in phase. So let's go over, use this opportunity to finally go over what is in phase means. So let's draw 1 cycle, 2 cycle. Let's call it X, let's call it Y. Let's call this is A, this is B, this is C, this is D, this is E, this is F. All right. The B is 90 degree out of phase with respect to A. C is 180 degree out of phase with respect to A. D is 270 degree out of phase with respect to A. And E is 0 degree out of phase with respect to A. So A and E is a wave, right? Is a wavelength. Not anything else. Not A and F. Okay, good. You get that. So in phase, you understand exactly what in phase means. So A to C, is this in pace? A and C in pace, but is it consecutive? No. So this is not wavelength. A to B, is this consecutive? Yeah, it is consecutive. There is no other point between. A to B is consecutive. Is this in pace? Yeah, A to B is in pace. So then this is, yeah, this is a wavelength. All right, now I'm going to quickly write. I thought I'm going to finish the wave in this tutorial, but it seems like I can't. This is already more than 1 hour long. So I have to make a separate tutorial, one for the sound waves and one for light waves. Sound wave is important. Why is that? It's because sound what makes us superior over other animals. And light waves, if we fully understand the light, that's going to make us superior over galaxies, if not the universe or multiverse. Because we never know if there is other intelligence out there, but probably we don't know. But understanding light not going to help us uh, make us superior over all the intelligent life in the universe, but also hopefully. Okay, so let's finish the final thing. The properties of waves and the characteristics. Speaking of properties, for example, this is Mr. Bari, and that is, let's say, okay, let's compare me with my two sons, Raf, who goes to Brown University, and Isaac, who goes to NYU. The properties we share, me, Raf, and Isaac share same properties. I have two hands, they have two hands. I have two eyes, they have two eyes. I have two legs, they have two legs. I have one head, they have one head. So we share the same properties, but we do not share the same characteristics. Yeah. For example, I like physics more, but Isaac like math more than physics. I like to don't know what. I like coffee. Isaac likes tea. I like, I don't know, I like, I don't know, I like to watch movie. Raf doesn't like to watch movie. This and that. Okay, all right, these are the characteristics. We don't share the same characteristics, but we share the same properties. So wave, all the wave share the same properties. All the waves share the same properties. What are the properties? We went over those properties: velocity, period, frequency, wavelength, amplitude, phase. All right, so all the waves, EM waves, mechanical waves, they have the same properties. Now let's talk about the characteristics. Number one, deflection. Number two, refraction. Number three, diffraction. Number four, Doppler effect. Number five, superposition. Number six, polarization. Reflection, theta initial equal to theta final. The phenomena is echo. The application of echo, we can find the distance we don't know. For example, the height of ocean floor with respect to the surface. Refraction, n1 sine theta 1 is equal to n2 sine theta 2. That's for light, but for sound, this is for light. For sound, that's totally different thing. Sine theta 1 over v1 is equal to sine theta 2 over v2. All right, when light changes or sound changes the medium, it refracts. Application would be like seismologists use earthquake. when the sound moves different layers of earth, they have an aha moment to understand the inside of the earth, like mental outer core, inner core. Diffraction. What is diffraction? Diffraction is when the lambda is bigger than the whole gap. You have the maximum diffraction possible. Okay. Diffraction is the bending of sound wave, right? So for light, diffraction is, this is for sound. For light, this is going to be a little tricky. A sine theta is equal to m lambda for a single slit. All right. Doppler effect. So when what is Doppler effect? Doppler effect, when the information coming from the source do not agree with the information receiving by the observer, right? When I am standing here, a truck is coming honking with 800 hertz. I will not experience 800 hertz. I will experience more than 800. I'm not going to be using calculator to calculate how much more, but I will experience higher pitch. And that would be F velocity plus minus V coming from the observer, V plus minus source. This is for sound, but light is similar. F is 1 plus V over C, 1 minus V over C. Let's put plus minus, then I'm covered redshift and blue shift both. Superposition, when two objects at the same location at the same time, there's superposition. Consequence, interference, positive constructive interference and destructive interference, right? That's very important because this the headphone is a consequence, is a direct, is a superposition in action. Well, is interference in action. All right, that is for the sound. For the light, the equation would be the same, almost same. For the sound, you're going to see use mu is equal to A sine omega t plus kx. This is for sound. For light, it's more or less the same. You're going to say the lambda for double slit, right? The Young double slit experiments shows that light, when you observe it, behave like a particle. When you don't observe it, behave like a wave. This is the distance you can find of the light from the highest intensity to, with respect to the highest intensity with the other one. So that's going to be lambda L over D. Lambda is the light goes through the double slit with some nanometers. L is the screen, size of the screen that behind the double slit. D is the gap. Not a gap. D is the, well, okay, we're gonna be explaining it. So this is double slit, so this is D. All right. The finally polarization, for example, this sunglass is a direct example of polarization in action. When the sunlight comes to our eyes, well, not sunlight directly comes, it's reflected and come back. The sunglasses save our eyes from the sunburn, right? So these are the things that we're going to be talking about. I thought I was going to finish this in this video tutorial, but not possible because this is already 1 hour or something like that. However, this video probably going to change your life, even when you go to graduate school. This is the probably, I don't know, most comprehensive tutorial in waves. It give you the understanding of 10 chapters, if not more. The full understanding this tutorial will give you. So you can use this understanding for not only physics, math, trigonometry, anything that that has to do with hard science. All right, I'll see you tomorrow.